So hi everyone, welcome back to Placements Ready. In this video we will be solving the problem delete nodes having greater value on right, and which has been asked in today's problem of day. So let's read the problem statement out. So we are given a singly linked list. Remove all the nodes in the list which have any node on their right whose value is greater. Not just immediate right but entire list on the right. So for example, in this linked list, we can see 12 is a node which is having a greater value on right. So we need to delete this 12. Similarly for 10, 11 is greater. So we need to delete this 10. For this 5, 6 is greater. So we need to delete this 5. Okay. And similarly, our output is going to be 15, 11, 6 and 3. In this example, for each of these nodes, there is a value which is greater on the right. So we need to delete all of these, and in the end our answer is going to be 60. So I hope you have understood the problem. Let's discuss the solution for this. So our example input is like this. Okay. So what we are gonna do here is that first of all, we will be reversing the linked list. Why? Because when we reverse that, keeping a track will be easier. So let's say if we reverse a linked list, our linked list will look like this. So our reverse linked list will look like this. When we will compare the data of these two, we can clearly see that the next node's data is smaller than 3. So we can directly point this pointer to here, and now this will not be taken into account. Similarly for 6, 5 will not be taken into account. So we can directly break this connection and we can make this new connection. Now here we can do a similar thing. So 11's next will now point to 15, and similarly for 15, since 12 is smaller value, so 12's next is nothing but null, so 15 next will be pointed to null. So in the end our linked list will look like this. And now what we can do, our answer was 15, 11, 6, 3. So you can clearly see this is nothing but the reverse of this. So we can again reverse the linked list. Okay. Now for reversing the linked list, there are two methods. One is the iterative method, one is the recursive method. Okay. So the iterative method takes a O of n time and O of 1 space, and the recursive method also takes a O of n time, but there is a auxiliary recursive space required, so that is big O of n. Okay, so it's upon you, you can use either of them. Okay, I prefer the recursive way because it's easier to implement. What we do in the recursive method, here we call the recursion for the next part of the linked list. Okay, so let's say our temp is pointing to this. What we will do, we will call the recursion on this. Okay, and let's say this recursion gives me a small head. Now what we need to do, we have to make this connection like this. Okay, so we will point temp next, then next. Okay, so 10's next is 2, but now we need to point this to this. So our statement will look like this. So temp next will point to temp itself, and temp next will point to null. So this next is will be pointing to null. Okay, so now as you can see, our this connection is made, and now for this we will call the recursion on the right part. Okay, so 2 will now return me the new head. So this connection will be made, and we can simply get this head at the end, and we can return our answer. So I hope you have understood the solution. So overall this complexity is going to be big of n only. Okay, time wise. So if you use the recursive method, the space complexity is going to be big of n. Okay, keep that in mind. So that's the approach. Let's discuss about the implementation. So this is our reverse method. Okay, what it is accepting, if my head is null or head next is null, means the linked list is containing only a single data. So in that case we will be simply returning our head. Otherwise we will call the recursive method on the next of head, as I told you, and we will point the head next to head itself, and head next will be pointing to null, and we can simply return our small head from here. So this was a recursive method. Now let's see what we are doing here. Okay. So first of all, what we have done, we have reversed the head. Now the temp pointer is pointing to head. Okay, while my temp next exists means I have something to compare with. So we can point the next of this node to the next of this node. Okay. Now, if that is not the case, we will simply moving forward. Okay. And in the end, we need to reverse our answer again. We can reverse that and we can return our answer. So I hope you have understood the solution. If you have understood, give this video a thumbs up and do share among your friends so that maximum people get the benefit out of it. And don't forget to subscribe our channel for more such videos. Thanks for watching.